Hello, welcome to the new video. In this video, I will discuss section 3.2.3 about pad control. So in the previous video, in the first video, we learned we have to include covariates or control variables x in the regression. And in the second video, we studied what happens if you do not include it, and also from the example we learned including some variables still help, right? Can still help. So in general, I recommend you to include more control variables as long as they are relevant, right? However, you should be careful because some controls can be bad. They are causing more troubles or different trouble, another types of trouble. So you should be more careful. So simply speaking, if a variable is an outcome, earlier I said a control variable is a determinant of your decision. But if a control variable is an outcome of your decision, that's the problem. You should not use that as a control. A variable, I recommend you to use a variable that is a determinant, not an outcome of the treatment decision. Then I believe it's easy to understand how we decide on the variables. Example from the textbook was the effect of college degree on your income. But the control variable is the occupation, whether you work in a white collar job or a blue collar job, for example. The problem here is that the occupation is actually a result of education, right? So if you did not for example, if you did not attend college, your occupation could be different, right? So occupation means occupation is different, is a result of your education. And in class I gave you a numerical example. So in that example, I assumed college attendance is perfectly random, and there is no treatment effect. But because of those occupation variables, your estimator looks like to have in your estimation, the college seems to have a negative impact. That was a numerical example I gave you in class. I'm not going to repeat that because it was the last class. So it causes another bias, a different type of bias. Simple, the intuition is clear. If you include occupation, that means you are comparing white collar workers without college degrees and to those with college degree. But as you can expect, they are different. They are not the same on average. For example, if you think about a professor who does not have any PhD degree but became a professor, that means that person must be super smart, right? There must be something else, right? To become a professor without a doctoral degree. So actually comparing this person to those with degree is actually unfair, right? Because there must be a huge difference in their unobserved abilities. And my favorite example is NBA players, comparing NBA players with and without playing college basketball. So I want to study whether playing college basketball improve basketball skills or not. So we have observations. So most players played college basketball, but some didn't. And this control group includes these guys, just to name a few. If you Google it, you should be able to find many more players. And parentheses shows the number of all-star selections. Okay. So then, now it's clear. It's unfair. Then, like, based on the data, it looks like college basketball, not playing college basketball, it is better for the player. So the players without college degree is doing better than those with college degree. But that does not make any sense. That's because becoming an NBA player without playing college already means they are exceptionally good, even without playing college. If they played college, they could be even better, but they don't need to, right? That's the bias we need to worry about when you include a control variable, or when you control something that is associated as the result of the decision. So in this case, not playing college basketball impacts whether the player plays in NBA or not. So NBA actually restricting the data to NBA players is like controlling for occupation. NBA player is an occupation, so that's a result of your college decision, right? So this is another problem, the other side of omitted variable bias, caused by including too many variables, right? So then going back to the table, actually that was estimated with occupation. So in the last regression includes all the variables considered up to here plus occupation, right? So occupation means like like professional job or education job. There are many occupations, and after including those occupations, the estimate decreased from 8.7% to 6.6%. So it looks like there was another significant drop in the estimated returns to education. Seemingly that is right, but I won't make that I won't take that interpretation, because occupation is can be a bad control. So it's hard to say. I cannot say that this estimate is a better estimate than this one. So this may have another bias. So I don't know how big, or I don't know the sign of that bias. So it's very difficult to tell what's going on in this estimate. So in practice, among these 5 estimates, I recommend this one. So this is the best estimator among these 5 candidates, and so this shows that it's not always better to include more control variables. When you it's in general, including more control variables can help you, but not always. That's the point you have to learn from this lecture. Okay. So this is all I prepared today, and maybe later, maybe on Thursday, I will record another video on chapter 3.3.1. Okay, so thank you for watching, and stay safe. Yeah, and see you on Thursday. Hopefully, by the way, there was another snow expected like this Friday or so. So I hope we can meet in the classroom on Thursday. Okay, see you later. Bye.